Good afternoon, learners. I am Dr. Munish Kumar Bharadwaj from School of Engineering and Technology of IGNOU. The topic is related to the course Transportation and Traffic Engineering, which is the course in 6th semester, and the course code for this course, as you know, is BCE 052. As it is clear from its name, this course is devoted to the transportation and traffic engineering, in which we have covered the highways, railways and airways. Today's topic is focused on highway engineering, and as you know, in highway engineering basically we deal with the roads and highways. First of all, why roads and highways are made? As you know, for transportation of man and material, we need good roads and highways so that the traffic can move easily and at a optimal speed, so that there is a fuel economy, there is a time saving, and as well as there is no damage to the traffic. So for that purpose we should prepare, or we should design and construct good road and highways. There is the need that why we should have the roads and highways. Now you must be thinking that what are the engineering aspect in designing and construction of highways. In the design and construction of highways, there are various steps, and first step comes when we plan a road or a highway. Means the first step is the planning. Means where should be the route, from which area, from which region a road or highway should pass. So there are many factors which govern this decision, that from which region or from which area a road or a highway should pass. These you must have studied in your course material that is provided to you. Now we will be discussing today the design aspect of highways with reference to the horizontal alignment or alignment of the roads. That what are the different features that are provided in the road so that movement of the traffic on the road is safe. Means there has to be considerations of the speed, there has to be considerations of the curves, there has to be consideration for super elevation, there has to be consideration for camber. These are certain factors that we will be discussing today. That how these roads are designed, or roads should be designed by considering these various factors, so that traffic movement is safe on the roads and the highways. So let's take one by one. First of all, as you see here, design of horizontal alignment takes into different factors, and these factors are, as I was discussing just now, first is design speed, second is radius of circular curve, third is type and length of transition curve. I'll tell you what is transition curve, why these should be provided in the roads and highways. Next is super elevation, and the last is widening of pavements on the curves. At some places we have to widen the pavements, and these places are where we are providing the curves on the road and the highways. So these are some design factors that we should consider while designing the highways or the roads. Now first factor is horizontal curves. How the horizontal curves are provided, what are the considerations, and why at all the horizontal curve should be provided. First of all, we will discuss about the need. The need of the horizontal curve you will feel when the road or the highway has to take a turn, because to reach at a destination it is always not possible to move in a straight line. We have to take some turn, we have to take some curves, and these are the locations where we have to provide curves on these roads. So these are horizontal curves, means to turn the direction, to turn to a particular destination. These curves are provided on the roads. Other type of curves that are provided on the roads or highways are vertical curves, and these curves are provided in the terrain where there is a undulated or mountainous terrain. Means you are rising on a hill, then going into the valley. There the curves provided on the road are the vertical curves. But here we are discussing about the horizontal curves, where we are changing the direction. We are moving in a direction, and to reach at a particular destination we have to take a curve. So we have to design a curve on the road or the highway. So what are the effects of introducing the curves in highways? So you must have felt when you are moving in a vehicle, in your car, in bus, or some transport, then you must have felt that when you are taking a curve, then you feel that you are being pushed to a direction, and that direction is depends on that which way the curve is moving. And if you remember, you are forced to move towards, or you are pushed towards the outer side of the curve. Why it happens? What happens, if you see this slide here, this is the vehicle, and this is the road, and if this vehicle is taking a left turn, in that case what happens, a force applies on this vehicle in the outer direction, outside of the curve, which is shown here by P, and this is applied at the vehicle at the CG of the center of gravity of the vehicle. If the CG of the vehicle is at a distance of h from the road, at a height of h from the road, and the wheelbase is B, means the distance between the two wheels is B. So the weight of the vehicle is acting downward, which is shown from by the letter W here. So W is the weight of the vehicle. So here, if we calculate it mathematically, then this centrifugal force P, which is acting on this vehicle on the outer side of the curve, this is WV square upon GR, where you know that W is the weight of the vehicle, R is the radius of the curve in meter, V is the speed of the vehicle in meter per second. So, and G, you know, this is the Earth's gravitation or acceleration due to gravity. So this centrifugal force can be calculated by this formula, P equal to WV square upon GR. So this much of centrifugal force is acting on the vehicle, and it is this centrifugal force, what it tries to do, it tries to push the vehicle towards the outer side of the curve. Now if you take this W on the left side, then this ratio P by W, we call it as centrifugal ratio or impact factor. Generally it is known by the name of impact factor. It is more common name. Then it is P by W becomes V square upon GR. So this is the unstabilizing force which is trying to provide the instability to the vehicle. Now this centrifugal force, what it does, it has two actions. First of all, it has a tendency of overturning the vehicle towards the outer wheel, towards the outer side of the curve, about the outer wheels of the vehicle. Means if that vehicle is moving that way and it is trying to take the left turn, then a centrifugal force will be acting on this vehicle towards the outer side of the curve, and it will have two effects. First effect is overturning of the vehicle. Overturning of the vehicle towards the outer side of the curve, and the vehicle will be overturned about the outer wheels of the vehicle. Second effect of this force is it has a tendency to skid the vehicle laterally outwards, means towards the outer side of the curve. If the vehicle is going this way, then this force will try to skid the vehicle towards the outer side of the curve. So these two effects are seen because of this centrifugal force P. Now, how to make our vehicle safe from these two effects of the centrifugal force? First of all, we take the first effect, which is overturning effect, and let us see that what balances this overturning force. This overturning force P is balanced by a movement, because this P is creating a movement P into H, which is trying to overturn the vehicle towards the outer side of the curve and about this you see here in the outer wheel of the vehicle. So about this outer wheel of the vehicle, a movement is created, and that movement is force into distance. Force is here P and distance is H. So P into H, this is the movement which is trying to overturn this vehicle about the outer wheel of the vehicle. Now to check this overturning, there is a movement which is provided by the weight of the vehicle. This weight of the vehicle is W, and this W into the distance between this CG line and the outer wheel, this is B by 2. So W into B by 2, a resisting movement or restricting movement is coming into picture here. So this movement W into B by 2 is providing safeguard or checking the vehicle from the overturning. So in equilibrium condition, means there is no overturning, means the two movements are equal, effect is neutralized. In that case, this such condition is equilibrium, and in equilibrium condition these two movements should be equal. Means P into H should be equal to B into W into B by 2, or P by W should be B by 2H. So this is the equilibrium condition. But to be always safe from the overturning, this P by W, we have seen that P by W impact factor earlier, and here this is the B by 2H. So to be always safe from the overturning, this P by W ratio that impact factor V square upon GR should be less than B by 2H. Means if we can design the highway such that that V square upon GR is less than B by 2H, then our vehicles will be always safe from the overturning. Means the vehicle will not overturn. So this is the meaning of it. So in this case, from these variables, what you see, what is in our control when we are designing the highway? First is the speed of the vehicle. You can restrict the speed of the vehicle. You can put the signboard before the start of the curve. That vehicle should not exceed this much speed. Second variable that we have in our hands, and which is directly in our hands, because even putting signboard before the start of the curve may not always force the driver of the vehicle to restrict to that speed. So that way this variable is not directly in our hand. Though you have cautioned the driver, then still it is not directly in our hand to control the speed of the vehicle here. But the other factor which is directly in our hand while designing the road is R. So we can, radius of the curve can be taken or chosen so as to keep this V square upon GR well within the limits of the B upon 2H. So this is the factor or the way by which we can make our road safe with reference to the overturning of the vehicles. Second thing is, second effect was transverse skidding of the vehicle because of this centrifugal force. So here let us see what mathematics of this highway design says. So P still is there. Now to counteract this P, we have the friction force that is developed between the road and the wheels, tire. So as you know from the mechanics or physics that if a vehicle is moving, then it is applying some load through wheels on the road, and there is a reaction from the road which is shown here as RA and RB. These reactions are acting upward, and because of friction between the road and the tire, there is friction force at this wheel FA, at wheel A, which is F into RA, where F is the transverse friction between tire and pavement. And at wheel B, at this wheel FB, this is F into RB. So these are the friction forces, transverse friction forces that are developed at the two wheels when the vehicle is taking a turn. And for equilibrium condition, that the skidding force as well as the counteracting force, transverse friction force, these two are balanced. In that condition, in the equilibrium condition, these forces has to be equal, and this P is equal to the sum of the two transverse friction forces. Means P should be equal to FA plus FB, and from the mathematics this can be written as P equal to F into RA plus RB. And as you know that RA plus RB, the total sum of these two reactions is nothing else than the weight of the vehicle. Means these reactions are, the sum of these reactions are, which are acting in the upward direction, the sum of these two reactions is equal to the weight of the vehicle. So you can replace that RA plus RB, the sum of the RA plus RB by the weight of the vehicle W. So finally this equation becomes in equilibrium P equal to FW, where F is transverse friction between tire and pavement. And from here, if you take the ratio P by W, then P by W is F, means transverse friction between tire and pavement. So for no skidding condition, that P by W, which we saw in earlier case, which was the impact factor, they are calculated that V square upon GR should here be less than F. Means this value V square upon GR should be less than the transverse friction generated between the tire and the pavement. So here again two things are here. Transverse friction means, if I make you to recall that if the tires are new, then this skidding situation does not happen or happens at a very high speed. But if the tires are worn out, then at lower speed also that skidding is felt in the vehicles. So first thing is the proper friction between the tire and the pavement. So at curves you can make, while construction of the curves, while construction of the roads, you can be cautious, you can be careful that the road should not be very smooth, means there should be some friction between the pavement and the tire. Second thing, second governing factor or second variable that you can control is the again the R, this radius of the curve. So by controlling these two things, you can ensure your vehicle from skidding at the horizontal curves. So these are the factors. Now another factor which is very important on the roads is super elevation, and this super elevation also comes into the picture at the curves. If you have studied or know about the camber, then I would like to clarify that this super elevation is different from the camber. The purpose of the camber is the proper drainage from the roads, even at the straight roads. But here the purpose of super elevation is different, though it also helps in drainage, proper drainage of the rainwater from the highways. But its main purpose is to provide safe riding at the curves. What happens that a transverse slope is provided throughout the length of the curve, and how it helps, we will see that how it helps in movement of the vehicle at the curves. Here you see in this picture, this is the vehicle, and it is the road's level has been raised to about a point which is seen here to about a inner point. So this was the original highway or original road. This has been lifted, this level of this road or the elevation of this road is lifted or turned about this inner point M at an angle theta. So now this continuous line MN is the new level of the road, this one, and now this has been shifted by an angle theta about this point, inner point of the road M. So when the vehicle is moving on this road, elevated road here, tilted road rather, not elevated. So P is acting, again that's centrifugal force, and this W, the weight of the vehicle, is acting downward. So let us see what changes have come in this new scene. So this ratio of this rise NL and this length ML is called as the super elevation rate. Means the rate at which the super elevation is being introduced across the road, across the width of the road. So this is the elevation rate. And if you see from the point of view of the trigonometry, then you will see that this ratio is simply a tan theta. So here this super elevation rate, which is the ratio of this rise to the width ml, it is the super elevation rate, and it is equal to tan theta. And when we are providing this theta on the roads, so this theta in practice is very small. And as you know, for small angles, for a small value of theta, tan theta is equal to theta, and also the sin theta. So we can replace this tan theta by sin theta, and from this triangle, if we look at sin theta, the value will be E by B. Means earlier it was E by ML, now it is this perpendicular divided by this MN, which is the width of the road B. So now you can write that the super elevation rate E is equal to E by B. E is the rise, B is the width of the road. So total elevation, so this is the rate of the elevation. So if we want to calculate this total super elevation height of the outer edge with respect to the inner edge, then we can simply write from this equation that E will be equal to this super elevation rate small e into B, width of the road. So this is the total super elevation height of the outer edge. Now what happens that in this case, when we have provided this super elevation, then if we look at that equilibrium condition, then what comes? If we take into consideration the horizontal forces, then what happens? This P, horizontal component of P is P cos theta, and horizontal component of this W is W sin theta, and there are two other factors in horizontal direction. These are FA and FB. So in this direction, if we take the sum of all these forces, then we see that P cos theta is acting towards the outer side of the road. W sin theta, FA and FB, these are acting towards the inner side of the road. So for equilibrium condition, there has to be balance in these forces. Means the forces which are acting towards the outer side of the road and the total sum of the forces which are acting towards the inner side of the road. So there has to be equilibrium in these forces. So if we write this condition, P cos theta equal to W sin theta plus FA plus FB. FA, FB, you know, we can write as F into RA plus RB. These are the reactions at the two wheels, here in vertical direction and here. Now RA can be written in terms of W cos theta, and RB can be written in terms of P sin theta. Means this RA and RB, RA plus RB, which is acting upward, these are the total reaction towards the up direction. These are balancing the vertical components of the downward direction forces, and these downward direction forces here acting as W cos theta plus P sin theta. This is equal to Ra plus Rb. Now from this, if we take the similar terms on one side, here P cos theta is there, P sin theta is there. So if we take here this F into P sin theta towards the left side, then we are left with P common, then cos theta minus F sin theta on the left side. And on the right side, we are having this W sin theta plus F W cos theta. This is on the right side. If we further solve this and divide the whole equation by W, then we will find P by W into 1 minus F tan theta. If we are dividing the whole by W cos theta, then we are left with on the left side this thing. On the right side, this we are left with the tan theta, because here W sin theta is divided by W cos theta. W cancelled, sin theta by cos theta. We are left with tan theta plus F. W cos theta is divided by the W cos theta. Then finally we can write it as P by W equal to tan theta plus F divided by this quantity on the left. It goes there in the denominator. Now for small theta, this F tan theta will be very small. So this whole quantity 1 minus F tan theta can be approximately taken as 1. In that condition, for small theta values, P by W can be taken as tan theta plus F. Now this is the impact factor, and as we know, tan theta is the rate of super elevation, which is a small e. This small tan theta is replaced by small e, so in that condition P by W, the impact factor becomes E plus F. And here if you remember in earlier case, in case of skidding, then we were left with F only. Here there is additional factor E plus F to safeguard us. So if we take F, the transverse friction between the tire and the pavement, as 0.15, then tan theta or the transverse slope is taken as 0.07. These are the specified values, or 1 by 15. Then F tan theta becomes 0.01. Means these are some standard values. F equal to 0.15, tan theta is 0.07. This is defined value. So this F tan theta becomes 0.01, and in this case, if we consider the overturning case, then what happens? P by W impact factor was calculated as V square upon GR. Here P by W equal to E plus F. This is equal to V square upon GR. And here this V is a small v we are using, means in meter per second. If we want to replace this speed in kilometer per hour rather than this meter per second, then we can write it as 0.278 V square upon 9.8 R. We have put the value of G here, 9.8. So in such condition, if we see this equation, E plus F equal to small v square upon GR in terms of the speed of kilometer per hour, then in that condition this E plus F becomes V square upon 127 R. So this becomes the governing equation, where we have provided the elevation, super elevation. Now, let us see the case of the equilibrium super elevation. Equilibrium super elevation, what is this new term? Equilibrium super elevation means when we are neglecting the transverse friction between the tire and the pavement, that we are considering that at curves there is no friction. If such type of condition is generated at the pavement, then the super elevation provided there at the curve will be called as equilibrium super elevation. So this equilibrium super elevation, in case of equilibrium super elevation, the centrifugal force will be fully counteracted by the super elevation only, because here we are not considering the contribution from the friction, transverse friction between the tire and the pavement. So in that condition, E will be equal to V square upon GR, means we have to provide the more super elevation. Understand? So E will be equal to V square upon GR, and this E is now called as the equilibrium super elevation. When we have designed the super elevation keeping in view or considering a case where the transverse friction between the tire and the pavement is 0. In terms of speed, when we are considering the speed in terms of kilometer per hour, then in that case E will be taken equal to capital V, which is the speed in kilometer per hour, V square upon 127 R. So this is a simply mathematical transformation of speed from meter per second to the kilometer per hour. So if you just convert this speed, then this 127 terms comes into the picture, and of course by putting the value of G also. So simple equation becomes here the E equal to V square upon GR. So this term, as you see from here, this term is having on the right side of this equation, you are having the two terms. V means the speed of the vehicle, and another term is R, means the radius of the curve. So in such condition, if this is the case, when E is equal to this much, means the super elevation, you have provided the super elevation E equal to this V square upon 127 R. If this condition is there, then what happens, that the pressure on the inner and the outer wheels will be equal. But, and which is the desired condition? Which is the desired condition? Because for comfort of ride, from the safety point of view, the pressure on both wheels should be equal. But to reach to that condition, to reach to that stage, we have to provide the large super elevation, because here we have missed the value of F, and we have taken the value of F as 0. The whole thing is being counteracted by the super elevation that we have to provide on the road. So more super elevation have to be provided in case of equilibrium super elevation. And advantage is that in such condition we will be having equal pressure on both the wheels. Now we can provide, to bring that safety and comfort of ride, we can provide that, but there is a limit to the maximum super elevation that you can provide. And why? Because our roads are not designed for a particular vehicle or a designed vehicle. Means we are not constructing road for only trucks. We are not constructing road or highways only for buses. We are not constructing any road is for the specific use by cars. We are designing and constructing the road for a mixed traffic. And in this mixed traffic, what happens actually, that we have, when we are designing a highway, we have fixed some speed, that, and we have provided the curve, radius of the curve, we have fixed the r, we have fixed a limit of the v, speed limit. Here now, when the road or highway is open for a mixed use, then there may be a problem for the vehicles which are moving at a slow speed. They will feel problem. So for such conditions where the roads are designed for a mixed traffic use, and that for that considerations, Indian Road Congress recommends the maximum super elevation limits, and these limits are, as mentioned in the IRC codes: plain and rolling terrain and snowbound area. In such areas, that maximum super elevation has to be restricted to 7%, means 0.07 value. In hill road, but which are not bound by snow, they may be up to 10%. Urban stretches with frequent interactions, the maximum limit of super elevation is 4%. And this is taken into consideration, keeping in view the convenience in construction and turning movement of the vehicles. So these are the limits that are provided by the Indian Road Congress. So this was all about the super elevation. Minimum super elevation is also restricted from some point of considerations. First of all, as I told you in the earlier, that there should be some minimum cross slope to drain off the surface water or the rainwater. So if the calculated super elevation is less than or equal to camber, then the minimum super elevation has to be equal to the camber. Means at least the super elevation equal to camber has to be provided there for drainage purposes. There may be some, at some cases, in some cases there may be negative super elevation, where it comes for very flat curves, normal camber may be retained, and that negative super elevation on the, in such condition what will happen, negative super elevation will be on the outer half of the movement. So here we will be restricting this discussion, and we will continue this discussion of the design of highways in our next lecture. So you go through your course material and find what is given there and try to understand it. If you have any problem, then we will discuss those problems in the next lecture. Thank you.